वॉइस क्वालिटी चेक। क्वालिटी कैसी है भाई बताना, आवाज आ रही तो। भाई इससे पहले वाला स्ट्रीम अनफॉर्चुनेटली यार क्यूट हो गया था लाइट की वजह से। भाई ये लाइव वाला क्यों नहीं दिखा रहा है यार? समथिंग वेंट रॉन्ग। भाई मेरी वॉइस आ रही है? कोई है ही नहीं अंदर लाइव में। भाई मेरी वॉइस आ रही है? कोई है ही नहीं अंदर लाइव में। भाई मेरी वॉइस आ रही है? कोई है ही नहीं अंदर लाइव में। क्या दिक्कत हो रही है यार? ये क्या हो गया भाई लाइव चैट में? भाई कौन है भाई? वॉच कर रहा है, कमेंट नहीं कर रहा है मेरे चैनल पे। बताओ भाई, कोई है तो यार क्वेश्चन पूछना यार, कोई है यार। ये लाइव कहाँ चला गया भाई? कैसे ठीक होगा ये? Can someone suggest me a game? Hello.
How to add background music to OBS for live streaming. Under the main scene where you need your music to be playing, you want to go to sources, click the plus sign, click media source, and then you want to name it background music. Hit OK, check loop, go to browse, find the music that you want to be playing, hit open, hit OK, and right now the music is here in OBS. So what you need to do, by the way, you can stop it, you can pause it, you can play. In order
So annoying. अब आवाज सही आ रही है?
on music, hit OK. Plus sign, click where you need your music to be playing. You want to go to sources, click the plus sign, click media source, and then you
फ्रेंड्स, वेलकम टू गेट वाला कंप्यूटर साइंस चैनल। आज हम कंपाइलर डिज़ाइन फर्स्ट सेशन स्टार्ट करेंगे और इस फर्स्ट सेशन में बहुत सारे चीज़ देखने वाला है और वेटेज कितना है गेट एग्जाम की, इंपॉर्टेंट टॉपिक्स है। और जो फर्स्ट टॉपिक लेक्सिकल एनालिसिस भी कवर करेंगे हम, ठीक है? या आर वी रेडी टू स्टार्ट? या गुड मॉर्निंग शशिकला, always in our niche Lalit gamers. Good morning. Yeah, sure, Shashikala. So I will use, I'll try to use, okay? Lalit. Yeah. We'll see introduction also, or phases of compiler, then lexical analysis, और last में कुछ PYQs भी आया है. We'll also see those PYQs in this session. Okay. Yeah, Shivam, good morning. First, compiler design में क्या क्या topics होता है? What are the topics are there in the compiler design? Okay. Now we'll just start with introduction. बट समझने के लिए हम क्या करने वाला है, और उसके बाद जो फर्स्ट चैप्टर है, व्हाट इज द फर्स्ट चैप्टर? लेक्सिकल एनालिसिस. नॉट मच इंपॉर्टेंट, बट समटाइम्स क्वेश्चंस आर देयर फ्रॉम हियर आल्सो. सिंटैक्स एनालिसिस. इसके अंदर टू टाइप्स ऑफ पार्सर्स है, टॉप डाउन पार्सर एंड बॉटम अप पार्सर. ये बहुत इंपॉर्टेंट है, वेरी इंपॉर्टेंट फॉर द एग्जाम. देन syntax directed translations और intermediate code generation, ये भी इंपॉर्टेंट है, ICG. और लास्ट कोड ऑप्टिमाइजेशन. एक और टॉपिक भी है, रनटाइम एनवायरनमेंट्स. और ये दोनों इंपॉर्टेंट है, बट सिंटैक्स इज मोर इंपॉर्टेंट देन अदर टॉपिक्स. ठीक है. वेटेज देखना है, इनकी वेटेज होता है मिनिमम गारंटीड 4 मार्क्स, बट मैक्सिमम 7 और 8 तक जा सकता है. तो एवरेज 5 और 6 होगा इनका कंपाइलर डिजाइन. सो एवरी ईयर 5 मार्क्स 6 मार्क्स, समटाइम्स 7 समटाइम्स 4, बट वेरी रेयरली 4, वेरी रेयरली 7. सो 5 एंड 6 आप मान सकते हैं. फर्स्ट इंट्रोडक्शन में हम व्हाट इज कंपाइलर एंड इसके बाद फेजेस ऑफ कंपाइलर देख लेते हैं. तो कंपाइलर जो है, इनकी इनपुट है हाई लेवल कोड, राइट? आउटपुट क्या होगा? हाई लेवल कोड सी, आर, सी प्लस प्लस, जो भी है जावा. तो कंपाइलर आउटपुट क्या होगा? यहाँ पर असेंबली कोड मान लेते हैं हम. एक्चुअली मशीन कोड भी मान सकते हैं, पर असेंबली कोड, ये टारगेट कोड, ऑब्जेक्ट कोड मान सकते हैं हम. ये टारगेट कोड. और यहाँ पर जो है, इससे पहले क्या क्या हो सकता है? एक प्री प्रोसेसर है. मोस्टली क्या होता है प्री प्रोसेसर? लेक्सिकल के अंदर एक पोर्शन होता है, इंप्लीमेंटेशन जो है, एक्चुअल इंप्लीमेंटेशन. सो प्रैक्टिकल इंप्लीमेंटेशन ऑफ द प्री प्रोसेसर इज देयर इनसाइड द लेक्सिकल एनालिसिस. बट वी आर ट्राइंग टू लर्न ओनली डिजाइन पार्ट, इसे हम अलग कर रहे हैं. एक्चुअली प्री प्रोसेसर फर्स्ट फेज में अंदर होता है लेक्सिकल के अंदर. तो याद रखना ये डिजाइन है, इंप्लीमेंटेशन एक्जेक्टली दिखना जरूरत है, बट सेम जो कंपोनेंट्स यहां दिख रहा है, सेम कंपोनेंट्स आर आल्सो देयर इन द इंप्लीमेंटेशन, बट सम ऑफ द कंपोनेंट्स कैन बी क्लब्ड. ठीक है. Then it is also high level. You can also include the pre-processor directives. So once the pre-processing does, the pre-processed high level code will be generated. So both are C only, but here the pre-processed code will be analyzed, and this actually does inside the compiler only. So after the compiler, what happens? You are trying to say assembly code, but assembler also there after this, and it is trying to produce machine code. Okay, so most of the people they say that what is the compiler output? Machine code. So they try to assume that assembly is also part of the compiler. So just in design, everything we just deal separately, but in practical, in real implementation, some of the components can be collabed to implement. Okay, after assembler, there is a loader and linker. Just to make ready, the code is executable. Okay, then the code is executable machine code. Right. So what is the compiler? Compiler takes high-level code and produces the assembly code or machine code, which is called as target code. Okay. Yeah, good morning, Prabal. Right. Sorry. कितने phases होंगे compiler में? Anybody? How many phases are there? Total 7 phases are there. This is intermediate code optimization and the target or assembly code optimization. Okay, total 7 phases are there. Okay, one phase, the name is code optimization, but both are different places. So we have different code optimizations. यहाँ पर क्या है intermediate code optimization and at this point assembly code optimization. Both optimizations are different. They may use common techniques, but they're not the same programs. Okay, there are different programs. Their input and output is different. And if you look at the input and output of every phase, we'll be having differently. Here, lexical analysis input is high level code. Maybe C you can assume. And output you will see some sequence of tokens. We call it as a token stream. And syntax analysis we call it as a parse tree, or some people call it as syntax tree. That's fine. And here annotated parse tree or syntax tree. And here we see intermediate code. And again optimized version of intermediate code. So example ये भी possible है. What is the input or output of each phase? They can give the two lists and find out one side they'll give the phases, other side they'll give the input or output. So you need to match accordingly. Code generated now, it produces assembly code. Target code we can call it as. And code optimization again it produces optimized version of assembly code. Okay, so this entire picture of the phases of the compiler. How many phases? 7 phases. And the first chapter is lexical, second chapter is syntax, and third chapter we don't study semantic, but we'll study syntax directed translation. This will be covered in the SDDs. And then intermediate code, and then code optimization. And code generator is not part of the syllabus, but you can just know what is a code generator also. Okay. Ready? The first phase of the compiler is called as lexical analysis, right? So now at each phase we have the errors. So can you tell me what are the errors that you see here? And all these phases are going to report the errors. We can call it as error handler. What we call error handler. And this can also report errors at every phase. Obviously, every phase can report some kind of errors. Okay. And also every phase can interact with one symbol table data structure. यहाँ पर आइडेंटिफायर का इन्फॉर्मेशन मेंटेन होता है इस सिंबल टेबल के अंदर क्या इन्फॉर्मेशन मेंटेन करता है attribute information of identifiers, right? Identifiers कंपाइल के लिए सिंबल मानते हैं तो इसलिए सिंबल टेबल है यहाँ पर. So every phase will interact with the symbol table ना. So जो lexical analysis report करेगा error का नाम होता है lexical error और lexical errors. Syntax analysis report करेगा syntax errors and then semantic errors जो type related information होता है. और ये तो internal system related fatal errors that mostly we don't handle it. The system का issues है we can't handle it. Okay, these are the user related errors. आप गलत टाइप किया होगा, गलत सिंटैक्स लिखा होगा, जो भी है तो that और ये तो internal system related fatal errors that mostly we don't handle it. The system का issues है we can't handle it. Okay, these are the user related errors. आप गलत टाइप किया होगा, गलत सिंटैक्स लिखा होगा, जो भी है तो ये आपकी प्रोग्रामर एरर्स बोलते हैं हम इसको. और ये जो है अगर सिस्टम मेमोरी कम है तो मेमोरी इनसफिशिएंट एरर्स जो भी है तो सिस्टम रिलेटेड एरर्स यहाँ होंगे. द फर्स्ट चैप्टर वो स्टार्ट करने से पहले इस एरर्स को एक बार एनालाइज कर लेते हैं. कितने टाइप्स के एरर्स है कंपाइलेशन में? मेनली वन लेक्सिकल एरर, सेकंड सिंटैक्स एरर. ये मेन टाइप ऑफ एरर्स है कंपाइलर से. कंपाइलर डिटेक्ट करेगा जो प्रोग्रामर का मिस्टेक्स. तो लेक्सिकल एरर्स क्या होता है? इस फर्स्ट चैप्टर में हम देख लेते हैं. लेक्सिकल एरर्स हो सकता है आप गलत कैरेक्टर टाइप किया होगा, है ना, जो पैटर्न डिफाइन किया लेक्सिकल एनालिसिस में. यू मे नॉट बी फॉलोइंग द पैटर्न व्हिच इज यूज्ड इन द लेक्सिकल एनालाइजर. सो लेक्सिकल एनालिसिस हैज अ पर्टिकुलर सेट ऑफ पैटर्न्स, वी नीड टू फॉलो देम. इफ यू फॉलो एनी अदर पैटर्न व्हिच इज नॉट डिफाइंड then it will generate lexical error. So lexical error is nothing but invalid sequence of characters might happen in the code, so it will produce the lexical error. Okay, maybe you know there are many rules like identifier should start with a letter but you start with a digit, that will give an error obviously because that is the kind of pattern followed by the lexical analyzer. Okay, और syntax errors में क्या हो सकता है? फर्स्ट सिंटैक्स में या दो सेमीकोलन बीच में होना चाहिए था बट सेमीकोलन की जगह कॉमा टाइप किया है तो एरर आएगा. तो सिंटैक्स जो डिफाइन किया है you have to follow the same syntax otherwise it will give you an error. एंड सिमेंटिक क्या होगा? आप देखो वेरिएबल इंटीजर डिक्लेयर किया है बट उसमें डबल का डेटा स्टोर करने की कोशिश कर रहा है तो you cannot store the double data in integer. Maybe you can store the character data in integer because the character is less size than integer. So some kind of errors you may see and sometimes without declaring you are using the variable. So that kind of errors also happens in semantic errors. So these things will happen, you know, you when you are writing C programs, when you are compiling you will get to know these kind of errors oftenly. Okay. Now the first phase of the compiler is lexical analysis. So what do you think about lexical analysis? Many things, right? Many things in lexical analysis. Can you think about what is this lexical analyzer does? So you are writing a program, it assumes that you are giving the character string. Complete your program just looks like a characters and it produces token string. Example, you might be writing a program like, you know, int x is equal 10 and main int let's say y, something like this you typed, and what it might do, it will produce something like this: t1 t2 t3 t4 t5 t6 t7 t8 t9 t10 t11 t12 t13, something like that. Okay, it recognizes some tokens here and it will produce the tokens what have written as the characters. So it looks at lexems, so it's trying to group the characters into lexem and each lexem it will produce a corresponding token. So what is lexem here? So what you have written, it's a kind of word. See, int is one lexem that you have written and corresponding token is there, like say t1. Actually t1 is representing a keyword, so int is one kind of keyword, and similarly x identifier, so it produces t2 kind of id, and equal is an operator, 10 is a constant, semicolon is you can say special punctuation symbol, or in every statement with semicolon, and main is a identifier name because main is just a function name, and special symbols you may assume that if you want it, int y semicolon and all these things, 1 2 3 4 5 6 7 8 10 11 12 13. So 13 tokens in some form it will be generating, and this is called as a token string, and this is your character string. And you may see a lot of things here, comments or spaces or new lines, all this will be ignored and just produces like a string, right? Yeah, so this is called as a token string, and what you have written is a character string. Is everybody clear? And in case any issue with this program, it will produce a lexical error, if any. It will report to the error handler. Okay, now this lexical analysis will also make entries into the symbol table. It will interact with the symbol table. Of course, not only lexical analysis, हर phase कंपाइल करने हर phase symbol table के साथ interact करेगा, और इसमें जो information modify करना है, enter करना है, वो इनकी responsibility है, ठीक है? इसमें क्या क्या एंट्री करना है? यहाँ x आया है और क्या y main आया है और क्या है? ये जो सिंबल जैसे दिख रहा है y. So every identifier के लिए information maintain करेगा. यहाँ पर तो ये एंट्री x किस लाइन में आया है और किस पैटर्न फॉलो किया है वो सब यहाँ पर, ठीक है, नंबर कितना है, जैसे t2 जो भी है, t2 इन्फॉर्मेशन मेंटेन कर सकता होगा, और 6 मेन तो t6 है, और y क्या है 11 है, t11 है, और किस लाइन में आया, लेट्स से ये 1 में आया, ये 2 में आया, ये 3 में आया, तो जो भी इन्फॉर्मेशन है इसमें मेंटेन करेगा, राइट। ये लेक्चर एनालिसिस का जॉब है, सिंबल टेबल में हर आइडेंटिफायर का इन्फॉर्मेशन मेंटेन करना है, सारी एट्रिब्यूट इन्फॉर्मेशन मेंटेन नहीं करेगा, सिंटैक्स आएगा कुछ और एंटर करेगा, सिमेंटिक आएगा कुछ और एंटर करेगा, सो अलग अलग इन्फॉर्मेशन मेंटेन करता रहेगा, और पूरा कंपाइलर के लिए सिंबल टेबल जरूरत है, पूरा कंपाइलर के लिए, क्यों एंड में क्या होगा, ये x जो है वो एक ऑफसेट एड्रेस बनके इसके अंदर स्टोर होगा, क्यों वो लास्ट में जब कोड जनरेट होगा असेंबली कोड में इनके लिए रजिस्टर और मेमोरी असाइन होगा, तो वहां तक इनका इन्फॉर्मेशन मेंटेन करेगा, मतलब लास्ट फेज तक इनकी सिंबल टेबल का इन्फॉर्मेशन जरूरत है, राइट। हर फेज में ईच आइडेंटिफायर के लिए क्या करना है, राइट। फंक्शन के लिए क्या जरूरत होता है, फंक्शन के लिए कितने आइडेंटिफायर है, ईच आइडेंटिफायर का टाइप क्या है, सब इसमें मेंटेन करेंगे, यानी तो मेन तो फंक्शन है, तो इसके लिए बहुत बड़ी वो होता है इन्फॉर्मेशन होता है, और रिटर्न टाइप भी हो सकता है जो भी है। ये लेक्चर एनालिसिस का outlook overview of the lecture analysis. What is the input, what is the output, what errors, of course errors will take time to understand. अभी तो स्टार्ट किया है ना, तो लेक्चर एनालिसिस का फंक्शनलिटी देखना है, अभी तो फंक्शनलिटी देखा नहीं, सिर्फ इनपुट एंड आउटपुट, एंड इट इंटरैक्ट्स विद द सिंबल टेबल एंड आल्सो रिपोर्ट्स एरर टू द हेयर हैंडलर। व्हाट आर द फंक्शनलिटीज, यू नो क्या क्या फंक्शनल्स होता है लेक्चर एनालिसिस के लिए, एनीबॉडी क्या लेक्चर एनालिसिस कर सकता है यहाँ पर, देयर आर मेनी फंक्शनलिटीज, ओके, एक एक लिखते जाएंगे हम। फर्स्ट फंक्शनलिटी क्या है, देखो जब इस प्रोग्राम को स्कैन करना है तो राइट ईच कैरेक्टर स्कैन करके एंड तक जाना होगा, तो स्कैन्स एवरी कैरेक्टर ऑफ द प्रोग्राम, एक कैरेक्टर को भी नहीं छोड़ सकता है, एवरी कैरेक्टर ऑफ गिवन फाइल और प्रोग्राम बोथ आर सेम, राइट। तो स्कैन करके क्या फायदा है, व्हाट इज द यूज ऑफ स्कैनिंग, एनीबॉडी, व्हाई इट हैज टू स्कैन, because compiler scanning means who is the first page, let's analysis it is scanning indirectly, okay, anyone, what is the use of scanning over entire program from first to the last character, there are many things to generate the tokens, correct, it recognizes many things, it recognizes spaces, new lines, comments and tokens, all these things is the job of lexical analysis. If the preprocessor is implemented in the lexical analysis, then preprocessor as a lexical analysis also does as include as defined, it is also part of the lexical analysis, but that's, you know, we are ignoring it, that's the job of preprocessor, and in many compilers preprocessor is actually the part of lexical analysis, while it's scanning preprocessor also works parallelly, तो आपको इतना, you know, difference नहीं होता lexical analysis preprocessor का, preprocessor इसके अंदर implemented होगा, of course lexical analysis का job अलग है, preprocessor का job अलग है, ठीक है। recognize ये करेगा, but produce क्या है, it produces tokens, और क्या produce करेगा, lexical errors if any, recognize तो सब करना पड़ेगा, but producing सिर्फ tokens and lexical errors if any, right, not only just produces, it also makes an entry into the symbol table, right, it stores attribute information, some attribute, not everything, some information of identifiers in symbol table. Symbol table में some information store करना होता है, so that is also job of lexical analysis. Every phase does some job. This line is there for every phase. Remember, not only lexical analysis, syntax also this line is there, semantic analysis, ICG, CG, CO, everywhere this line is there. Okay, not only for lexical. Remember that. This is applicable to all the phases. All phases does this job. Okay, not only for lexical analysis. Remember this point. Okay, apart from this, anything that you know about it? Anybody guess? Without identifier, Shubham Maurya, you are writing the C programs. You're writing any program in the world. You identify your name, right? Name is identifier. And in programs, what is identifier? Variable names, function names, what are they called as? It recognizes spaces, new lines, comments, and tokens. It has to recognize, and after recognizing, only it produces token, not all of them. These are ignoring. It produces tokens, and one more point, it has to ignore these three. Okay, it deletes or ignore. What are they? Spaces, new lines, white spaces basically, and comments. See, ignore recognizing everything, but this three will be deleted, and this one will be produced. That's why this is covered in fifth point, and that is covered in third point. This is produced, and this one will be deleted. Both has to be recognized by the lexical analyzer. Okay. How to recognize the token? So while scanning, it's going to group the characters. How to recognize? ये functionality है. It groups characters. Both has to be recognized by the lexical analyzer. Okay. Produced. That's why this is covered in fifth point, and that is covered in third point. This is produced, and this one will be deleted. Both has to be recognized by the lexical analyzer. Okay. How to recognize the token? So while scanning, it's going to group the characters. How to recognize? ये functionality है. It groups characters into tokens with the help of longest prefix match rule. What is the rule name? Longest prefix rule. Also called as maybe you can call maximal munch. Okay. So the longest prefix it is going to use while grouping the characters into tokens. Okay. And if anybody want to use designing techniques, it can take help of finite meta and regular expression. Okay. So other 2 points which are application related. Before writing a program, को क्या करना है? Design करना. Rule. What is the rule name? Longest prefix rule. Also called as maybe you can call maximal munch. Okay. So the longest prefix it is going to use while grouping the characters into tokens. Okay. And if anybody want to use designing techniques, it can take help of finite meta and regular expression. Okay. So other 2 points which are application related. Before writing a program, को क्या करना है? Design करना होता. To design lexical analysis, you can take help of. So finite meta can be used to design. Okay. For implementing, you can take help of any programming language, C, C++, Java, Python, anything. Used to design lexical analysis. Not only finite meta, you can also use regular expression to write the patterns. Okay. Mostly, people may not aware of something. Let me write here. Pattern, lexeme, token, or finite meta, regular expression. आपको regular expression pattern बोलता है same. Right. Pattern is something, let me write one example. Just let me write one example. If you don't understand, just leave it. Pattern is, suppose I want letter, very famous pattern. Letter followed by any sequence of letters and digits. If you want this, follow this pattern, you can use regular expression directly. Meta and regular expression. Okay. So other 2 points which are application related. Before writing a program, को क्या करना है? Design करना होता. To design lexical analysis, you can take help of. So finite meta can be used to design any programming language, C, C++, Java, Python, anything. To write okay, most may not aware. Now you can also use regular expression to write. Not only finite meta, you can also use regular expression to write the patterns. Okay, mostly people may not aware of something. Let me write here. Pattern, lexeme, token, or finite meta, regular expression. आपको regular expression pattern बोलता है same. Right. Pattern is something, let me write one example. Just let me write one example. If you don't understand, just leave it. Finite meta, regular expression. आपको regular expression pattern बोलता है same. Right. Pattern is is something, let me write one example. Just let me write one example. If you don't understand, just leave it. Pattern is, suppose I want letter, very famous pattern, letter followed by any sequence of letters and digits. If you want this, follow this pattern. You can use regular expression directly, like letter followed by letter or digit whole star. And what is L means? L means here A, B, C, lowercase or uppercase, you decide it, okay? And D means digit, 0, 1 or 2 or till 9. So this is how you represent a regular expression. If you study TOC, you will know what is regular expression, okay? What is lexeme here? So you will write a corresponding representation. Maybe you are using identifier rule in some programs. What's that represent letter, right? Okay, I'm just using something X, Y, Z, 1, 2. See, this is XYZ1, 2 is following this rule. XYZ, first X is here letter and followed by any sequence of letters and digits. The letter is there and then any sequence. Even after I can write also that works because letters and digits I can write in a sequence. So this is what a lexeme that you write. The token you can keep as it is or you can give some name like T1. You write grams. Pattern. You can use regular expression directly like letter followed by letter or digit whole star. And what is L means? L means here A, B, C, lowercase or uppercase. You decide it, okay? And D means digit, 0, 1 or 2 or till 9. So this is how you represent a regular expression. If you study TOC, you will know what is regular expression, okay? What is lexeme here? So you will write a corresponding representation. Maybe you are using identifier rule in some programs. What's that represent letter, right? Okay, I'm just using something X, Y, Z, 1, 2. See, this is XYZ1, 2 is following this rule. XYZ, first X is here letter and followed by any sequence of letters and digits. The letter is there and then any sequence. Even after I can write also that works. Because letters and digits I can write in a sequence. So this is what a lexeme that you write. The token you can keep as it is or you can give some name like T1 or T10, whatever. That depends on what token you want to follow. Is it keyword or ID? If it is identifier, let's say you can give your own name, ID1. Okay. Finite data. So to represent this regular expression, you may design a finite data something like this. Letter and followed by any sequence of letter or digit. Of course, L means the 26 symbols are there. I cannot write out 26, that's why I written L. And here 26 and 10 digits are there. So total here 36 transitions are there. Here 26 transitions are there. So this is what finite looks like. So to right now, with the help of this, you can write a program. You can implement Lex analyzer just using function names. Let me write this F1 and let me write this F2. So you can use the function F1 within that. Okay, ch is equal get char. Okay, what is it? Is it L? Oh, if ch is equal to L, I will call the function, let's say F2. Okay. And in F2 also you can write another function similar to that. If nobody is coming, then it's accepted. If anybody coming, only letters and digits. So similarly, you can write for F2. You can write a program. You can implement Lex analyzer with the help of the finite data. Because here almost the required information is there to implement a program. What F1 should do, what F2 should do. So you can write your own functions to implement Lex analysis. You got overall picture of the Lex analyzer. Of course, I did not mention every function of the Lex analyzer because the functionality of the Lex analyzer is so big. I can't help you to design everything. It takes days and months to write, or days at least, not a month. Maybe 10 days, 15 days. You can implement all of them. Okay, if you study them. Okay, how to recognize the space and how to delete it, how to recognize the new line, how to recognize the comment, and how to recognize the tokens. Everything you should write a program. And among them, you should only produce the tokens. If any issue is there in the program, you should produce the Lex layer. Then you should know when the Lex layer should happen. So this all matter is very important. Then, while recognizing the token also, you should follow longest prefix rule. Then what is the longest prefix rule? How to implement with the help of the program? All of them should be mixed in one program. Okay. Today mostly Lex analysis and parser are together. But anybody want to implement separately, that's okay. You can do it. There are many Lex tools out there. Okay. Now let's talk about the token. The word token, of course, is nothing but type of lexeme or sequence of a group of characters that is recognized as a token. There are so many tokens are there in many programming language. Anybody knows what are the tokens you will see? One is identifier. You should know, right? Just token word is not enough. What do you mean by tokens? Identifiers. What else you have? Keywords that you study. What else you see? Operators that you study in programming languages. What else you will see? Apart from this, anybody? Constants or literals. And apart from this, any special symbols or punctuation symbols like semicolon, parenthesis, brackets. Okay. In C, you will see these 5 types, but in other programming languages, you need to follow according to their understanding. You might know what is identifier. In C language especially, identifier means it can start with letter or underscore and followed by any sequence of letters, digits, underscore. But you should not start with the digit. Okay. Remember identifier. That's why this identifier could be variable name or function name. The names that we use in programming language are programs. We call them identifier. The names are symbols for the symbol table. That the symbol word here. Identifier, nothing but it's just a name given to the variable or function. And you may use in other places like structures, many places, but just simply say variable and function names. Keywords, there are 32 keywords in C language, and you may look at them. Operators, there are various types of operators: arithmetic, relation, logical, bitwise, and you can go with them. And constants, again, character. What else? What are the constants are there? Character and integer, float are real, and string constants. And in integer, there are many types again: hexadecimal constant, octal constant, right? Decimal constants. There are various types of constants again. And punctuation symbols that I told already: semicolon, or open parenthesis or close parenthesis, brackets. These are comes under punctuation symbols. Okay, these tokens you could have learned in any programming language. So if you are good at this tokens, you will know how the lexical analysis works. Okay, directly help. If I am going to teach all of them, indirectly I'm trying to teach a programming language that I don't want to dare. Okay, so anybody interested to learn the tokens, please go to any programming language. You can find what is identifier, you can find what is keyword, how many keywords are there, what are operators supported by that programming language or compiler, and what are the constants. Every programming language will not have the same rules. Remember, rules for framing this tokens can change, and different programming language will have a different number of keywords, different type of operators. Identifier rule may change, right? And constants rule may change, and punctuation symbols too. Okay, so if you learn any programming language in the world, these things will be easy for you to understand. But what we are doing here, C, compiler design. So learn the C tokens only. Other tokens may not help you much because in exam they will talk about C only. Now we'll go to the longest prefix rule. What is the longest prefix rule? Anyone? What is longest prefix rule? Suppose we are writing M-A-I-N. When you look at this group of characters, M looks fine. It's valid. Even A is also fine. I is also fine. N is also fine. But it's not telling you 4 tokens. What it is trying to do? M, valid. A, it's trying to find the longest from here. I, valid. And N, valid. When the space comes, it automatically separates the tokens. This main space. So this all together is 1 token, not 4 tokens. When will be counted as 4 tokens? If you give the space M, or give semicolon, or give comma, anything. M-A-I-N. Now this time you cannot group them. Why? A character is alone. Now this time the M is alone. So total how many tokens here? Here 4 tokens. For this it is just 1 token, but for this it is 4 tokens because of the spaces. Now longest, see, now this is the longest because you cannot club this because of space is there. When the space comes, it separates the tokens. Not only space, to separate the tokens, there are many things in the we need to follow in lexical analysis. Okay, so space is one of the reasons why we separate the token, but space not required. Even semicolon comes, this is the token, and it also separates it. Okay, sometimes operator is a token, and it also separates the tokens. Okay, there are, other than the space, there are many other symbols can help you to separate the token. The parser trying to help lexical analyzer how to separate the tokens all the time. If the lexical analyzer alone it cannot do, suppose it is not able to do it, then parser will help you when to separate the token. Okay, what is the longest prefix rule? Okay, now I'm going to ask you many things here. Plus, how many tokens? Okay, plus, and how many tokens are there? Plus, minus, plus, equal, plus, triple, plus. Okay, now look at this and tell me how many tokens are there each one. 1, 2, 3. Now it will help you to understand what do you mean by token using longest prefix rule. Okay, I'm waiting for your answer. Okay, I'll be here, but waiting for a minute. Ullman Rachit. That's a standard book. Answering. I'll be looking at your answers. I'm looking at, and I'll discuss. Okay, still answers are coming. Okay. Can we discuss one by one? Everywhere, it's going to scan, correct? So when the scanning starts from here, the plus is a valid, but double plus is also valid. It's an increment operator, either pre or post you will use, right? This is completely a single token. Everybody agree? It's just 1 token. Now again we'll start scanning from here. Compiler does there, right? Less than, valid token, but longest we need. And double less than we'll use for left shift, right? And double less than equal, it's assignment operator. How many of you know x equal to y? It means x is equal x left shift y, right? You know the compiler how it evaluates x is equal, right? Longest we completely a single does there, right? Less than, valid token, but longest we need. And double less than we'll use for left shift, right? And double less than equal, it's assignment operator. How many of you know x equal to y? It means x is equal x left shift y, right? You know the compiler how it evaluates. There is operator, there is a single operator, so it considers as a 1 token. Okay, it has a meaning. It has a meaning. Okay, it is a 1 token. If it is not having a meaning, it can separate, but there is no separation required. Correct? Assignment operator, we have this kind of left shift followed by equal. Shorthand operator it is. Now plus, minus. So now any operator in the world together, it is 1 token. And if I mix the minus, will it be any operator in the world? No, right? So this is the 1 token. I start scanning here, and now minus is another token. Here 2 tokens will come. Okay. Now plus equal to, yeah, there is a operator, you know, x plus is equal y. Similarly, you can say this is x is equal x plus y, internal meaning, right? You have a meaning for plus equal to. So now when compiler starts scanning, the plus is the value token and plus equal is the longest, then it will take as a one token. Okay, there is no longest, then it will not take, right? There is the longest here. The plus minus is not the longest value token, so we'll just take the plus. Now mine equal to plus. Equal is fine, but equal plus is not a one token, right? Equal plus is not a one token. There are two different operators, and there's a one token, and again start scanning is another token. So two tokens will come here, and another token. No longest, then it is the longest equal to. So now you can say this is x is equal x plus y, internal meaning. Right? You have a meaning for plus equal to. So now when there is the longest here, the plus minus is not the longest. Equal plus is not a one token. There are two different operators, and there's a one token, and again start scanning is another token. So two tokens will come here. And यहाँ पर when it starts scanning, you know, till double plus it considers one token and other plus is one token. So total two tokens. Total two tokens. So many of you are correct? Like 1, 1, 2, 1, 2, 2. So this is how you answer, right? First question, second, third, fourth, fifth, sixth question. How many of you answer correctly? This is how you need to identify the tokens in the program. Wait for your answer, okay? Using similar, but try to understand the pattern first. They have clearly mentioned what is this symbol, x question mark symbol. It means 0 or 1 occurrence. Read the complete data. Just take 2 minutes and answer it. Okay, option D is not visible. The option D is T3, T3. This is option D. Okay, you can take the time around 2.5 minutes. Start poll, single choice. What is the answer? Shubham. After this. So everybody answered correctly. What is input? This is input, right? So now you look at which one is going to give the maximum first. Take the longest from here. B does after them, right? B, you can take A or epsilon, you can take epsilon here. B and B you can take here, B you can take. So everywhere B does after them, right? B, the long, you look at which one is going to give the maximum first. Take the longest from here. B does after them, right? B, you can take A or epsilon, you can take epsilon here. B and B you can take here, B you can take. So everywhere B is possible. But after that, one more B required. One more B if you want here, you can repeat here itself. So one more B is here. And if you want one more B, you cannot stay here, you have to go there. And one more B you want, you can take from here. So double B is possible from all of them so far. B, B, A. A if you want, double B, A you have to go here. And if you want one more A, impossible here. And A it's possible here. So in T1, T3 is possible. And we want one more A. So double B here. So okay, after that input I will change, then let's see the answer. Then let's see after this. So everybody answered correctly. What is the input? This is the input, right? So now you look at which one is going to uh, give you the maximum first. Take the longest from here. B does half of them, right? B, you can take A or epsilon, you can take epsilon here. B and B you can take here, B you can take. So everywhere B is possible. But after that, one more B required. One more B if you want here, you can repeat here itself. So one more B is here. And if you want one more B, you cannot stay here, you have to go there. And one more B you want, you can take from here. So double B is possible from all of them so far. BBA. A if you want, double B, A you have to go here. And if you want one more A, impossible here. And A it's so far. BBA. A if you want, double B, A you have to go here. And if you want one more A, impossible here. And A it's possible here. So in T1, T3 is possible. And we want one more A. So double B, double A we want. See, now double B, one A you can do. One more A you cannot. And one more A you can do here. So B, B, A you can repeat here. And we want a C, and that is only possible here. After C you can't get anything. So up to here you can get a T3. What you can get? T3. And so A it's possible here. So in T1, T1 you can take from here. So double B is possible from all of them so far. BBA. A if you want, double B, A you have to go here. And if you want one more A, impossible here. And A it's possible here. So in T1, T3 is possible. And we want one more A. So double B, double A we want. See, now double B, one A you can do. One more A you cannot. And one more A you can do here. So B, B, A you can repeat here. And we want a C, and that is only possible here. After C you can't get anything. So up to here you can get a T3. What you can get? T3. And now you should start scanning from here. A, you should start scanning from here. A is done, can be done you should start scanning from here. A, and then AB. Next, A, B is here. Correct? And then done, can be done by everyone. Correct? And then AB. Next, AB. A, B is here. And A, B is here. A, B is here. So AB is also does by everybody. Is done, can be done by everyone. Correct? And then AB. Next, AB. A, B is here. And A, B is here. A, B is here. So AB is also does by everybody. And ABC. Now A, B, C is here. And A, B, C is not possible. A, B, C is possible. Now T1 and T3 both are ABC looks like, but T1 is not yet complete because A should be there to make it valid. Just half of the portion you can't take. If it is there, A, B, C, A is there, this is valid. But now this is a A, B, C, A is there. This is valid. But now this is a complete string A, B, C. Now see, properly whole T3 is matching, but whole T1 is not matching. Still A require. If A is there, at least you can go for T1. But because of that, C. Now see, properly whole T3 is matching, but whole T1 is not matching. Still A require. If A is there, at least